Hey everyone, so this is the second video that I'm doing on variant Sudoku. This is the second entry in the Rat Run series. So I'm glad that I got such a positive reception to the first video that I posted. This is going to be a similar one. It's actually not a 9x9 Sudoku. It's actually an 8x8 Sudoku with 2x4 boxes. And I'll explain the rules in a moment. If you want to try the puzzle after I explain the rules, that'll be linked in the comments, as well as the import settings and all the other stuff you need in order to play the puzzle. But I'm going to go ahead and get started and read the rules here. So normal 8x8 Sudoku rules apply, so I have to put 1 through 8 in every single row, column, and 2x4 box. Exactly once. It says no digit repeats in a row, column, or box. So typical rules for how the rat is able to move, and the test constraint for this puzzle in particular. Oh yeah, so all of the different puzzles have a sort of play on words in the title, and I should have picked up on this. The first one was called Rat Run 1 Primer. Now, primer because for two reasons. It's the first entry in the series, and also, the theme of the puzzle is it has to do with prime numbers, right? And so this one is called Tenacity, and the test constraint here is that any two adjacent cells along the correct path must sum to at least 10. So that means if the path were to look like, well, I'm just going to do a really simple one. This is probably not the actual, probably not the actual solution. What it would mean is that these numbers, these two right here, have to add to at least 10. It could be exactly 10, it could be more, it can't be less. These have to add to at least 10, as well as these, and these, and these, and so on, right? So anyway, again, if you want to try, without being spoiled, this is your last chance, but I'm about to start. So let me go ahead. How do I do this again? Oh yeah, restart here. And I'm going to start the timer in 3, 2, 1, start. Okay, so as usual, I'm going to go ahead and mark out all of the possible paths that the rat can take. Like this. Sorry, for some puzzles it might take a while. I can go in a 2x2 here, and I can go in the 2x2 diagonally here. Okay, so we can either, well, first thing we can do, we know that this part of the path is for sure going to be used, and then we can also sort of eliminate parts of the path that we know definitely will not be used. So let's see here. What can we do? I guess I can't quite, What can we say about this Sudoku? Any sort of general statements about it? I imagine I'm going to be going up here and doing all sorts of stuff before coming back down to the cupcake, but I'm not exactly sure. Maybe we can try to disprove. Well, what happens if I do this? If I try to connect to the, is there any reason that doesn't work? Oh yeah, okay. So here's a simple reason why we can't go straight across. So remember the constraint that says that every pair of numbers has to sum to at least 10, but also I have to put 1 through 8 in every single row, column, and box, and crucially this row. So let me ask you a question. Where do I put the 1 in the bottom row? I can't put it anywhere, can I? Suppose I put it here. Well, the problem is that it needs, this pair of squares needs to add to 10, and this pair of squares needs to add to 10. But that's not going to work because I would have to put a 9 here in order to make it add to 10, at least 10. But there's no 9 in this puzzle. I can only use the digits 1 through 8. So this does not work. I actually have to put a 9 in both locations. Oh, it's this stupid thing again. Sorry. I don't understand. Let's turn that off. For some reason, if I turn the conflict checker on and then back off, that fixes it. But anyway, so I can't do this for two reasons. I can't put the 1, actually I've noticed something else interesting as well. I can't put the 1 here because I have to put a 9 in both of these positions, which I can't because they see each other, they're in the same row and the same box. And also there's no 9 in the puzzle anyway, right? Even putting the 1 in the corner like this, that doesn't do me any good because I still have to put the 9 here, but there's no 9s allowed, right? So this is not going to work. And then the other thing that I mentioned is a little bit strange. I will mention it later if it comes up. So I know the rat has to go this way. I know it also has to go this way eventually. I know I have to use this part of the path. I also know that I'm going to visit this square, but I don't know exactly how, because it's got to come to the cupcake from, like, this side of, you know, it has to, imagine now we're traveling backwards from the cupcake to the rat, right? It has to either go this way or this way, you know, by one way or another, it's got to visit this square. So I'm just going to put, a circle in it. What else can I say here? Oh, you know, another thing, yeah, so I can't actually visit this square, because then all 8 cells in this box are visited, and that's impossible for the same reason that I can't visit every cell in the bottom row, because I'd have to put the number 1 somewhere in the box, but you can't put a 1 anywhere without putting a 9 next to it, which isn't allowed. So I cannot visit this square, so I can remove all the connectors to it. So I will either go over like this, or I'll go diagonally across here. Okay. Is there anything else interesting that I can say? Okay, well, here's this. So, let's think about the sorts of numbers. Yeah, let's think about the sorts of numbers that can go next to other numbers. So I have to have at least 10. What can go next to an 8? Well, anything except a 1, right? Even if it's as low as a 2, 8 plus 2, that does still work, right? A 7 has to be 3 or above. A 6 has to be next to a 4 or above. A 5 has to be next to a 5 or above. And that's, a 5 can be next to a 5. You know, suppose these squares were both 5s here. They don't see each other. They're not in the same row, column, or box. So those could both be 5, for instance. 4 has to be next to a 6 or above. 3 has to be next to 7 or above. 2 has to be next to 8 or above. But that's just 8, right? That 8 is the highest number that's allowed. And then 1 can't be next to anything. So what I've noticed here is that 2 has to be next to 8. This is what I noticed earlier, but I'm just now seeing how I can use it. Where does... Oh, well, actually... Yeah, okay, couple things. First of all, where does a 1 go in this box? I've used every square except this one, so that has to be where the 1 is. And then secondly, where does the 2 go in this box? Could the 2 go here, for instance? It could not, because a 2 can only go next to an 8, which would mean that these have to both be 8s, and that's not allowed. In fact, a 2 cannot go in any internal square, right? A 2 has to be either here, so it can be next to an 8 like this, or it has to be here. Well, no, let's see here. It could be here, and then be next to an 8 here and here, or something, but not here and here. Or, I suppose a 2 could go here and then be next to an 8 and then be next to something else, right? So the only places a 2 can go, actually that doesn't narrow it down a whole lot, but it's got to be in one of these... Oh, no, it can't be here. No, it cannot be here because it would be 8 and 8, like this, right? So the 2 has to be, sorry, in one of these 2 positions, right? It cannot be anywhere else, or else it would be next to 2 squares that are both on the path that would see each other because they both have to be 8, right? And wherever the 2 is, if the 2 is here, that's an 8. If the 2 is here, that's an 8. So one of those 2 is 8. If the 2 is here, that's the 8. If the 2 is here, that's the 8. Right. Okay. Interesting. I guess we can also say that because the 1 is here, the 1 cannot be in any of these squares in this box, so it has to be in one of these. Well, I guess one of these. It can't be on the path, right? But that doesn't really narrow it down enough for me to think that it's, like, worth putting down. Okay, so yeah, either that's a 2 or that's a 2, and wherever the 2 is, the 8 is next to it. Okay. What else can we say? In fact, if this is the 2, then I have to skip diagonally across, because I have to put the 8 here and here. I can't put the 8 here and here because they see each other. But if this was something other than a 2, like if it was a 4, then I can go like the long way around if I wanted to. So that doesn't really help. Huh. I'm wondering if there's maybe some way that I can disprove this path here. But I'm not quite seeing how. Because I can use 7 squares in a box as long as the 1 is unused. And then this would be the unused square. I certainly can't take all 8, right? But I could take all 7, and then these ones, you know, that's fine. Maybe I need to look at this box again. Where does what's the next most restrictive digit is a 3? Where does a 3 go? Oh, well, you know what? A 3 can only go next to an 8 or a 7, can't it? Well, no, I was going to say something that I thought was smart, but it actually doesn't make sense. I was going to say, let's suppose that this is a 2, whoops. Let's suppose this is a 2 and this is an 8. Where's the 3? Well, I can't put it here because it has to have an 8 and a 7, but the 8's already used. I can't put it here because it has to have 8 and 7. I can't put it here because it has to be 8 and 7. I could put it here because it could have a 7 here and then an 8 in one of these. But I could also put it here because it could be 8 and then 7 like that. And yeah, so that basically limits 3 to being, whoops, no, in one of these 4 positions. But that doesn't feel like it's worth marking, so I won't. You know, this 1 sees all of these squares, and these 2s also see all of these squares. I could not put a 2 here, because then there's nowhere to put it in this box, right? Wherever the 2 is, it's either here, and then there's a problem, or it's here, and then there's a problem. So I know the 2 has to be in the bottom row. The 1 and the 2 have to be both in the bottom row, in fact. 1 has to be in one of these. 2 has to be in one of these. The 2 can go in the corner, but it would force the 8 here. What else? Gosh, this is tough. Oh, you know what? Gosh, this is so obvious. Why didn't I see this? So, in fact, I was thinking I can easily disprove this, but in fact, the rat has to go here. I cannot go this way around. I can't take this path. Pause and see if you can figure out why. Why can't I go this way around, regardless of how I approach it from this box? Because I would be using every cell in the leftmost column. And again, I run into this exact same problem where I have to put a 1 somewhere in the column, but I can't put anything next to it. Marty Sears is so clever in the way that he, like, you know, you pick up on something that you're supposed to do in the puzzle, and there's several instances where you can immediately apply it. It's always like your attention is always directed at like where you ought to look next. Okay, so anyway, we can say that this path is definitely not used. The rat must travel this way, and now I can make the deduction that in fact this is not allowed because I would be using all 8 cells in this box, and then again I can't put the 1 anywhere, right? So this is unused. I must jump across diagonally. And because I jump across diagonally, where does the 1 go in this box? It can't be on the path, so it must go here. Alright, we're getting through this puzzle. I think it's a little tougher than the last one. Okay. I know that I must use a 1 in one of these squares, but I'm not going to mark across boxes like this, because otherwise it looks like I'm saying the 1 in this box must go here, and the 1 in this box must go here, which is not necessarily the case. In fact, it's definitely not the case. Okay, let's see. Oh, and again, we can do this exact same logic with the 2s and the 8s in this box. So where does the 2 go in this box? Remember, 2s can only go next to 8s, so the 2 can't go here, because it forces me to go 8 and 8. A 2 can't go here, or it forces me to go 8 and 8, right? A 2 can't go here, or here, or here, or here. It has to be on the end, right, in one of these 2 squares. And wherever it is, the 8 is next to it. Okay. What do I do now? I suppose... Well... Okay. I don't think it's possible to use this piece of path right here. And that's because it would use every single square in this row, wouldn't it? These four are definitely on the path. This one is on the path, we just don't know how. So if I were to take this loop here, well, that's a problem because every square in this row is used, and that's not allowed because we would have nowhere to put the one, so this part of the path cannot be used. And I must go either here or zigzag across this way. And all of those look fine for now. I was going to say that I can't do this because I'd be using most of the cells here, but that's still fine. I can leave one out, and that has to be the one with the 1 in it, and it's here. So that's fine. Okay. This is only a minor deduction, but I can't use this path here, or else every cell in the top right box would be used, right? These have to be used because I can't go in and come out this way because there's only one path leading into it, and then vice versa. Yeah, this connector cannot be used. There's no way. I would visit every cell in the box if that were true. I mean, that hardly matters, but... in fact, it's not going to be possible to use all 4 of these squares, right? Because then this entire column is used. But I could use these and not this. Or I could use these and not these, so... Maybe I need to think about how these two boxes interact with each other. Oh, well, here, this is interesting. Yeah, this is actually such a clever... I don't know if this was intended, but check this out. Can I put a 2 here? I want you to tell me what is going to go on the other side of this 2. Well, it has to have an 8 on both sides of it. But I can't put an 8 here, because we know the 8 in this box has to be here, one of those 2. So that's not allowed. In fact, actually, here's an even easier way of saying it. Suppose I were to put the 2 here. I have to put an 8 here. But then where do I put the 2 in this box? I said it had to be in one of these 2 squares, but I can't put it here because then I have a 2 next to a 2, which is 4, which is less than 10, of course. And I can't have the 2 here because, of course, the 2's see each other. So the 2 in the... What the heck is going on? Why is my keyboard acting up? Oh, I'm on the wrong tab. Okay. So yeah, this cannot be a 2, right? So the 2 must go here. The 8 must go here. Oh, and we can use the same logic in reverse. I can't put the 2 here because I have to go 8 and 8, and then the 2 8's see each other like that. So this must be where the 2 is in this box with the 8 next to it that way. Okay, we're getting somewhere now. Whichever of these 2 squares this 2 connects to, that is where the 8 goes, but I don't know which one it is. Oh no, of course I know which one it is. Surely I can't use this path here, because a 2 has to be next to an 8, and I would have an 8 and an 8 that see each other. That's not allowed. So I can't use that. I can't use that connector. So it must travel this way. So this has to be the 8. And then it goes here and does something else. I'm not quite sure. Okay. Now what? Maybe we should take a look at 3s again. Yeah, okay. Yeah, let's look at 3s. So, where does the 3 go in this box? It could go here and then be next to an 8, 7. Remember, 3s can only go next to 8s and 7s. The 3 could go here and be next to that 8 and then a 7 there. But it can't go here because I'd have to have an 8 and a 7. But the 8's already used. by the same logic, the 3 cannot go here, and it cannot go here. It could go here. The 3 could go here, and it would be next to a 7, and then a 7. That is fine. So the 3 is in one of these, and if the 3 is here, then that's a 7, and if the 3 is here, then that's a 7. So in fact, one of these is a 7. It doesn't tell me that much, though. Maybe we'll do the same thing up here. Yeah, we'll do the same thing here. So, where is the 3? It has to be next to an 8 and a 7, so it can't be here, can't be here, can't be here. But it could be here and be next to 7, 7, or it could be next to here and then be next to 8, 7. So the 3 is in one of these, and wherever it is, the 7 is next to it. Okay. Let's see here. Oh, we can do the exact same thing we did with the 2s and the 8s, but with the 3s and the 7s. That's so cool. Can a 3 go here? Well, at first it might look like it can. I would put a 3 here and then 2 7s there, but we said a 7 can't go here. The 7 has to be in one of these two, right? Because where would the 3 go? The 3 goes there. You see, that takes the place of a corner marked 3. So the only space left in the 3 for the 3 in this box is here, so the 3 would go there, but then it has to have a 7 next to it, and now I've got 2 7s in a box, so that does not work. So the 3 cannot go here. It must go here. It must be accompanied by a 7. Oh, there's like a, oh yeah, this 3 in the corner thing. That's like some, you know, dumb inside joke from the, I'm just going to go ahead and turn it off so it's not distracting. Oh, it is already off. All right, looks like I got to turn it off again, just like the conflict checker, whatever. Okay, so there's no 7 there. Oh, this 7 sees this 7, right? So this 7 means that's not a 7. 7 must go there in this box. And so the 3 can't go here because it wouldn't be next to a 7. So the 3 has to go there. And I wonder if I can now do the same thing with 4s and 6s. Yes, in fact, if this was a 4, well, 4s are next to 6s, 7s, and 8s. So this has to be... Yeah. Where does the 4 go in this box? It can't be here, because I have to have a 6, 7, and an 8 in these. But I have to put a 6 in both, because the 7 and 8 are already used, so that doesn't work. So the 4 can't go here. 4 is either here or here, and then in here, same logic. 4 is either there or there, right? Oh, but wherever the 4 is, actually, yeah, wherever the 4 is, it'd have to be next to a 6. Here and here, right? So actually... these are 4 and 5 in some order. Now, okay, well, we can immediately resolve that, because if this is a 4, this sees that square, so it can't also be a 4, it would have to be a 5. And then this sees this square, so that has to be a 4, but then I have 4 plus 4 is not 8. Or sorry, 4 plus 4 is 8, which is not at least 10. So this cannot be a 4, it must be 5. So that's a 4, that's a 4, that's a 5, and then I have 5 plus 5, which is 10, which works, right? Okay, we're a quarter of the way done in terms of the numbers being filled in. It probably means we're more than a quarter of the way done, to be perfectly honest. Okay. I mean, I know that these are 1, 2, 5, and 6, but I don't want to mark those in just yet. Maybe I'll do it here. Yeah, this is a 1, 2, 5, and 8. And this is a 3, 4, 6, 7, right? In other words, these 4 numbers have to go here in some order, because these see all of these squares, so I can't put any of these in any of these. So these have to go here, and these have to go here. In fact, that's always true in a 2x4 Sudoku is, you know, like these are going to go here, sorry, here, these are going to go here, right? Anyway. Oh, you know what actually I've noticed now is this part of the path must be used. I could have gotten that a while ago. You guys probably noticed that, but Yeah, we can go this way around. We just don't know what happens in between. Okay, well, here's something I can say. This cannot be a 1, because it has to be next to, well, it can't be next to anything. A 1 can never be on the path, ever. So that's definitely not a 1. And this cannot be a 2, because a 2 has to be next to an 8, but I can't put an 8 here. This is only 3, 4, 6, or 7. It would see this 8, right? So that's not a 2 either. It's either a 5, and then this has to be 6 or 7, or this is an 8, and then this can be pretty much anything. Okay, so the 1 and 2 live here. I'm not sure where. Maybe there's some reason that this is not possible. No, seems doable. I was thinking I could maybe limit myself with like the 3, because the 3 could only go next to the 7 and 8, but it would only be the 7, right? But I just realized I could put like a 3 here, an 8 here, a 7 here, a 4 here, and a 6 here. So that does work. Well, I've noticed something kind of interesting. Yeah. Where does the... Oh! This is even simpler. Can the path go this way around? Of course not, because that uses every square in this box. But again, I would have nowhere to put the 1. So I can't go this way. I must go up, and in fact, whatever crazy stuff I do here, I must eventually take this path. Now, I must be careful. I can't use every single path I can't use every single square in this box. I could dip up here and then come back down and then go around. And then I use every cell except for this. Or I can go this way and then I use every cell except for this. But I can't take both, right? In fact, all of these squares are on the path. So where does the 1 go in this box? The 1 must be here. Because I have to put it off the path. In fact, that also means that the 1 has to be over here. Actually, in one of these two. Where does the 1 go in this box? This 1 knocks a 1 out of these two. This 1 knocks a 1 out of these two. And these 1s, wherever the 1 is, whether it's here or here, doesn't matter. I can't put it in either of these. So the 1 in this box goes here. I'm just not sure where. I could put the 1 here and just avoid that path, right? Okay, anything else I can get? Like, I can say that the 1 in this box must go here. It certainly can't go there, but it could go in any of these, but I'm not going to mark it if there's 3. This is actually interesting. Where does the 1 go in this box? It must be off the path, so it must be one of these. But wherever it is, in any of those 3, I actually will mark this, because this is interesting. Wherever the 1 is in any of those, it can't be in any of these, right? In another way of looking at it in reverse, if I were to put a 1, say, here, it would mean that none of these are 1s, so one of these must be a 1, but I can't put a 1 on the path. So that's not a 1, right? The 1 has to be in the bottom row, and in fact it has to be in one of these two. So I've either got 1s this way around, or I've got them this way around. Not sure, but I assume I'll figure out at some point. Okay. Interesting. What else can I do? I feel like I kind of got stuck. I'm actually just going to go ahead and mark these. 1, 4, 5, 6, 2, 3, 7, 8, and I know that's not a 1 because it's on the path. Okay. What do I do now? Like, I can see, for instance, that these can't be a 3, 4, right? But there's no way I can't just remove 3s and 4s from here, because one of them could be a 3 or a 4, and then the other not, right? see something mildly interesting. Yeah, okay. Look at this box. This might not be what I'm supposed to find next, but it is interesting. Where does the 2 go? Oh, no, you know what? I was about to say something that I thought was smart, but actually didn't make sense. Yeah, no, that doesn't work. I was going to say the 2 must be in one of these, by the same logic as before, like down here. It has to be on one of the ends, because it has to be next to 2 8s. But again, the 8s can't see each other. And that would allow me to force a 2 into the top row, but of course this 2 sees that one, this 2 sees that one, and then the 2 can't go here because it would be 8 and 8, and that would allow me to put a 2 here. The reason I can't do that is because a 2 actually could go in one of these, and then I wouldn't use either of these squares, right? I would just go straight through. So that doesn't quite work. Okay. I don't want to just be staring at this for a while and there be some silence. Oh, no, yeah, okay. So, no. I was about to say I can't, yeah, well, this is still true. But I have no way of marking it. I can't use all 4 of these. I remember how I said you can't use all 4 of these because I'd have nowhere to put the 1. Right? Because the 1 has to be on the... has to be off the path. But I also cannot use all of these, because where would I put the 2? The 2 can't go here because it's already in the box. Sorry, not in the box. Sorry. 2 can't go here because it has to be next to an 8 and then another 8, but it would have to connect to either this, this, or this, but I can't put an 8 in any of those because there's an 8 there. I can't put a 2 here. Oh, no, could I? You know, yeah. Because a 2 has to connect to 2 8s, right? Where are they? It only connects to these. This is not an 8, this is not an 8, this is not an 8. Actually, that's not an 8 either. Yeah. The 2 can't go there because that would be 8 and 8. The 2 can't go here because that would be 8 and 8, or 8 and 8, or 8 and 8. Neither of those work, right? So if all 4 of these squares are used, I would have nowhere to put the 2. So that cannot be the case. But again, I have no way of marking it. What I do know, though, is that... Oh, well, no, actually, I can now eliminate this path. Because if this path were to be traveled, I'm using every single cell. Yeah, I'm using every single cell in this column. So this does not work, right? And then I would know where to put the 2, as I just mentioned. So we're going to go this way. And actually, that sorts out this 1 issue. The 1 can't go here because the 1 has to be off the path. So the 1 goes here, so it's this way. Right? And actually, that now means I can't use this square because the 1 is on it. So I have to either go diagonally or I zigzag like this. Okay. That helps quite a bit. So I see a little bit of a strange effect here. If I go up and then to the left instead of diagonally, the only place I can put a 2 in this column where it's either off the path completely or next to 2 8s is here off the path, which forces me to put a 2 in one of these, which means that I have to go straight across. So taking this means that I must do this. But going diagonally gives me the freedom to, mess around in the top right. But there's not, I'm not going to mark that. There's not really any way to. I guess what we can say, this is mildly interesting, is these have to be 2, 5, and 6 in some order. These have to be, 4, 5, and 8 in some order. Oh, there it is. Okay, so... yeah, think about this. I claim that the 8 must be in the middle. Can you see why? If the 8 were not in the middle, suppose the 8 were up here without loss of generality, then these would be 4 and 5, but 4 plus 5 is 9, which is not allowed. Of course, I could just as well say that the 8 goes here, and then these are 4 and 5. Likewise, that's not allowed. So the 8 must be in the middle. So that is an 8, for sure. So neither of those are 8. Those are 4 and 5 somehow. And in fact, this square, well, if this is a 5, yeah. If this square is at most 5, this has to be at least 5. So this has to be 5, 6, 7, or 8. Whoops, I meant to do it this way. That has to be 5, 6, 7, or 8. Except it can't be a 5 or an 8 because it sees those. So get rid of these. It's a 6 or a 7. Now what? Oh. Yeah, so, okay. This 4 or 5 must connect to one of these squares. Whichever one it connects to, what do I put there? I can't put a 1, 2, or 3, because that's too small. I can't put a 4, 5, or an 8, because these numbers see both of these squares. So it has to be a 6 or a 7. So it's sort of strange, but there's a 6 or a 7 up here. Whichever one is not there is in one of these two. So I can definitely say there is no 6 or 7 in this square. Because if there was, suppose I put a 6 here, this would be a 7, and that would force the 2 and the 3 here, and that would there's nothing for the 4 and 5 to connect to that's valid. So this is not a 6 or a 7, and vice versa. If this was a 7, this would be a 6, and then same problem, right? So that's not a 6 or a 7. It's not a 1 or a 4 or a 5 or an 8. So what's left? Just 2 and 3. That's somewhat interesting. And this is these two, whichever one... Oh, well, hang on a sec. No, I can't quite say that. Yeah, okay. This connects to a square, either this one or this one. Whichever one this connects to is the other 6 or 7, whichever one is unused up here, and then whichever one it does not immediately connect to is the 2 or the 3, whichever one is unused up here. Oh, well, yeah, in that case, I can't go this way, right? This would be a 4 or a 5. Oh, no, it does work. Yeah, it just barely works. Yeah. Okay. Yeah, it just works. I was going to say it would force me to... But it would force me to add 2 that are less than 10, but it could be the 7 and the 3, leaving the 6 and the 2 up here. So either of those is fine. Okay. I do also know now that the 2 in this box is either here or here, because it certainly can't be in any of those, because it sees that 2. So the 2 is either there or there. That doesn't really do much for me, so I'm not going to mark it. Gosh, what am I missing? Something so obvious. Oh, let me go ahead and mark the rest of this column. What is that, 3, 4, and 7? Now, these have to be either 3 or 7, or 4 or 7. They can't be 3, 4, right? So the 7 must be up here. So the 7 is definitely not here. And that is going to finish it, because where does the 7 go in this box? It can't go here, or here, or here, or here, or here, or here. It must be one of these. The 7 has to be in here somewhere. Whichever of those 2 squares it's in, this cannot be a 7. It has to be a 6. So I can take the 6 out of there. So I know that there's a 7 here. I'm just not sure where. I can now say that's not a 3, because 6 plus 3 is 9, which is not at least 10. So that's a 4 or a 7. So I've got a 2, 5, I got a 4, 5, I got a 4, 7, I got a 2, 3, and then I got a 3, 4, 7. Yuck. Okay. Oh. No, not quite. Yeah, that doesn't quite work. Can this be a 3? If it was, this would be a 7, because it certainly can't be an 8. But if this is a 3, this also has to be a 7. This would be a 2, this would be a 5, this would be a 4. Yeah, that all works. Okay. The funny thing about these puzzles is I'm like disappointed when something works. I want something to not work so I can eliminate it and go with whatever the other option is, right? Alright. I'll tell you what. I don't think I can put a 2 here because it has to be next to, it would be on the path, it'd have to be next to 2 8s, which would make this or this an 8, which is not allowed. But I could put a 2 here. You might say, well, it has to be next to 2 8s, so I have to go 8 and 8. But that's not the case. It could just be off the path completely, and I just go this way around, right? There's some elegant piece of logic that I'm missing here. I've been hung up on this section for quite some time now. Oh. Well, hang on now. See, that barely works. I was gonna say, okay, I know these are not 2s. This also cannot be a 2, because what would it be next to? A 3, 4, or 7. None of those are big enough. Could this be a 2? It would have to be next to an 8 here, and then an 8 on the other side, which is not here, because it sees that 8, but it could be one of these. It could have an 8, yeah. It could be like 2, 8, and then something else. Actually, in fact, it would have to be this one. Because this 8 would see this 8. So it would be, I could go like 2, 8, you know, 3, 7, 6, 4, 5, or something like that. Yeah, that works. So that could be a 2. I was hoping I could limit the 2 to these, because that gives me a 1-2 pair, and it takes 2 out of this and puts it here. But I can't quite do that, at least not at the moment. Or maybe I can, and I can't quite see how. So this is 2, 3, and 7. Except we previously deduced that's not a 2. In fact, I'm just going to go ahead and take the corner marks out. Alright. In fact, it feels incredibly difficult for this to be a 3. No, I suppose it could. Yeah, it could be a 3. If this is a 7, this is a 4, this is a 5, and then I go up like this. That'd make this a 2, and then a 5, and then a 4. 7, 3. Yeah, that's fine. Okay, well. What am I missing? There's something blindingly obvious that I'm not seeing. Oh. Well, no, not... Okay, the 3 is in one of these 2 squares here. Wherever it is, there can't be another 3 in the rest of the row. So the 3 in this box must be up here. Now, either I've got a 3 here, which has to be 7, 8, right? That's the only way that's going to work. Or I have a 3 here, and then I've got 7 and 8 this way. Or I've got a 3 here, and then it's either unused, or I've got the 7 and 8. Oh, well, no, you know what? If the 3 is here, it can't be on the path, because I'd have a 7 and an 8 here, because that's the only one this connects to, right? But then the 8 would see this 8. So the 3 is either off the path here or on the path here. in fact, we can now say that the 8 is in the top. Does that help at all? Well, sort of. No, it actually doesn't. I was going to say it eliminates 2 from here, but it doesn't even do that. Because it could go 2, 8. I could go like 8, 2, 8. Yeah, the 8, well, yeah, no, that doesn't... Man, what in the heck am I missing? Maybe it's like this row or something? Yeah, that's it. So where does the 2 go in this row? Okay. Yeah, I need to look for where the path is. Those are the rows and columns that I should be looking at. The rows and columns and boxes that have a lot of path in them. So the 2 is in none of these, obviously. The 2 can't go here, because it would be next to a number that's too small, 4, 5, or 6, right? It can't go here because it has to have 8 and 8. It can't go here because it has to have 8 and 8. And it can't go here because it has to have 8 and 8. So the 2 can't go in any of these or in any of these, so the 2 must go here. And that is going to completely crack this left side wide open. So the 2 goes here. Whoops. 2 goes here. That forces a 5 here. It forces a 6 here. 4, 5. Well, that's not a 2. This is a 3. This is a 3 and a 7, or a 7 and a 3. But either way, the 3 is used, so that's the 4. I suppose another way of saying that is, where does a 4 go in this box? There's only one place for it, and it's here. That's now a 7. That's now a 3. That's a 2. I guess I can't quite figure out the 3 and 7 yet. I do know, actually, that the 5 connects to the 7 wherever it is. But it could go 5, 7, 8. Or it could go 5, 7, 3, 8. Those are both acceptable. Oh, well, I guess we can now say, what does the 3 connect to here? 3s are only next to 7s and 8s. That's not an 8 because it sees this 8, so it must be 7. And I can at least eliminate 7 as a candidate from all of... Whoops, brightness up. I did not mean to... What did I press for that? Is it this one? Nope. Is it... How do I change the brightness? Whatever. I hit something on my keyboard by mistake. Anyway, have we done all the eliminations over here that we can? It looks like we have. I mean, now we know that these are 4, 5, and 6 somehow. And these are 1, 2, 3, and 8 somehow. Except that these can't be 1s. Nor can they be 2s, actually. Oh, no, this could be a 2. This could not. Yeah, because it'd be next to that. In fact, it can't be a 3 either. Yeah, this must be 8. Because it can't be a 3. It has to be next to a 4, 5, or 6. Right? Even 3, 6 is not big enough. So that only has one option. That's an 8. So none of these are 8s. This can't be a 2 because it'd be next to a 7, and 2 plus 7 is 9. So that's 3. So it means neither of these are 3s. So that's a 1 and a 2 somehow. And in fact, wherever the 2 is, the 2 can't be on the path, because it would be next to either a 4 or a 5 or a 6 down here. None of those are big enough. So I actually cannot use any of these squares, and I must go directly across like this. Something else I can see is this cannot be a 4, because I have to have a 5 and a 6, or a 6 and a 5 on either side of it. Whichever way around the 5 and 6 are, the 5 can't be next to the 4, because that's too small. So that's not a 4. Actually, it can't be a 5 either, because it'd have a 4 and a 6, or a 6 and a 4. And then the 4 and 5 are too small. Actually, that must be 6. So these are not 6. In fact, I can do some eliminations. These are not 3. These are not 8. And these are not 6. Okay, cool. And then what is this? It can't be a 4, 5, or a 6, because those are already seen in the same row. It can't be a 1, because it's on the path. It can't be a 2 or a 3, because they're too small. So it must be a 7 or an 8. But then this could be just about anything. Is there anything else I can do here? I assume these will be sorted out, as will these. Well, I must put a 2 up here somewhere because of this 2, and it can't go there. 4, 5, and 6 all have to go down there. If this is a 4, 5, or 6, what is that? It has to be at least a 4. It can't be 3 or lower, because then it would add to something less than 10. So it's at least a 4. What can it be? It could be a 4. It could be a 5. It could be a 6. It can't be a 7, and it can't be an 8, because those are already seen. And now here's a sort of an advanced trick, but take a look at these 3 squares. This is a 4, 5, or 6. This is a 4, 5, or 6. And this is a 4, 6. That means the 4, and they can't all, none of them can be the same as each other because they're in the same column. So the numbers 4, 5, and 6 have to be in those 3 cells in some order. I don't know how. If I made this a 4, then that's a 6 and that's a 5. If I made this a 5, then this is a 4 or 6. This is a 4 or 6, so the 4 and 6 go in that way. If this is a 6, then this is a 4 and this is a 5. However you slice it, you can't put a 4 or 5 or 6 anywhere except here in the column. I couldn't put a 4, 5, or 6 anywhere else because I would run out of numbers to put in those 3, right? So this can't be a 5. Suppose it was a 5, then there's no 5s here. So this is a 4 or 6, this is a 4 or 6, this is a 4 or 6. I can put a 4 or 6 in 2 of those, but not all 3. So that's not a 5. That doesn't do a whole lot, but it's something. So it's a 4, 5, 6 triple is what that's called. This is now either a 1 or a 2 or an 8. Not that that helps very much either. In fact, one of these must be a 6, because what happens if neither of them is a 6? Then it's a 4 and a 5, but that adds to 9. So one of these has to be a 6. Whichever one it is, it's going to see this square, which cannot be a 6 now, and must be a 4. Regardless of whether it's on the path or not, only because I know these two both are. So neither of those are 4. That is a 5 and a 6 in some order. I suppose I can take 4 out of all of these. And now, no, I can't quite do that. Well, what's this? It can't be a 3 or below because it would connect with this and be too small. So it has to be 4, 5, 6, 7, or 8. Could be a 4. Could be a 5. Could be a 6. And it could be a 7. Yeah, that's not as useful as I hoped. In fact, I'm not even going to mark it. What else do I do here? Is there some sort of deduction I can make maybe down here? Feels incredibly difficult. No, I was going to say it feels difficult for this to be a 3. Because I have to go 6 and 7 or 7 and 6. And then 3, 6 is a problem. But it could be a 6 here, and then the 3 just doesn't connect to it, and it just goes up the other way instead. Where does the 4 go here? I guess it could go just about anywhere, couldn't it? That doesn't help. What am I looking at? Oh. No. I was going to say, where does the 3 go in this box? I feel like it's probably up here. It's certainly not here. And it can't be here because I just have a 7 and an 8 on either side of it. But then I have a 7 or an 8 here, a 7 or an 8 here, and then a 7 or an 8 here. That's too many 7s and 8s. But I suppose it could go here and then be next to a 7 and then an 8, couldn't it? Yeah. 3, 7, 8. That does put a 3 here, which puts a 7 here. Yeah, that just barely works. Oh, no, it doesn't. No, I can't put a 3 here. Yeah, I cannot put a 3 here. It has to be next to a 7 and an 8, right? Which of these is the 8 and which one's the 7? Well, this can't... So if this is a 3, right? Sorry, if this is a 3, it has to be next to a 7 or 8. This can't be an 8 because it sees this 8. But it also can't be a 7 because then what would I put here? I've removed every number from here, and there's no number that would work. So this can't be a 3. This can't be a 3. This can't be a 3. One of these is a 3. And whichever of these is the 3 sees this square, which means this must be the 7, and that's the 3. And I know I can't connect a 5 and a 3, so I take this out, and I must go this way. Okay, that helps a bit. Actually, it helps a lot, because this 7 sees that square. That's not a 7 anymore. That's got to be an 8. And that 8 is going to see this square, which is not an 8 anymore. That's a 5. And a 5 can't be next to a 3, so that's not a 3. I can also take 5s out of these, and out of this. And I can take an 8 out of here. In fact, I can do a lot of eliminations. Actually, this can't be a 5 anymore because it sees that 5. That's a 4. That's a 5. This is not a 5. This is not a 4. An 8 can be next to basically anything, so that doesn't... Yeah. Okay. No, that works. Oh, well, obviously this is not an 8 anymore. Yeah, so, okay, check this out. There must be a 1 in one of these, there must be a 2 in one of these, and there must be a 3 in one of these. So those must be 1, 2, and 3. Actually, I could have just noticed that every other number is used in the row. Why do I always have to do the things the hard way? Anyway, so that's 1, 2, 3, and 8, so this is 4, 5, 6, and 7. So what can I take out? That's not a 4 or a 5. That's not a 6. That's not a 5. Yeah. What do I do now? Oh, well, this is either a 6 or a 7, and this is either a 6 or 7, so this can't be a 6, because it would put a 7 into both of these. So that has to be a 1, which makes this a 2, this a 1, that's not a 1, nor is that... That's not a 2. In fact, that has to be, again, that can't be a 7, because we'd put a 6 into both of those, so that's the 3. So these aren't 3s. This is not a 1. What else can I say? This, no, I can't quite do that yet. Could this be a 2? If it is, it's off the path, because it'd be next to this, which is too small. This is a bit minor, but I can say, okay, what is this? No, let's do it this way. What's this? If this is a 6, that's a 5. That's a 7 in order to be big enough next to this 5, and that's a 4, right? So if this is a 6, that's a 4. If this is a 7, then this is not a 7, right? So if this is a 7, that's not a 7. If this is a 6, that's a 5, that's a 7, that's a 4, and therefore this is not 7. So in either case, it's not 7. That doesn't actually help all that much. Oh, this is not a 1. I could have gotten that a while ago. So this is a 4 and a 5 somehow. If this can't be a 4, because then there's nothing left for this. It can't be another 4, because obviously they see each other, and it can't be a 5, because that's too small. So that's not a 4. And there we go. I only have one spot left for the 4 in this box, and it's here. So this is a 6 and a 7, so this can't be a 6, it must be a 5. This C is a 5, so it's a 6. This C is a 6, so it's a 4. That's a 5. Everything is still open. I can go in either of those paths. What else is there to do here? I'm surely oh yeah, where do I put a 3 in this column? No, there's 2 places for it, never mind. Man, this is tricky. What am I missing? Well, here's something I can say. The 2 in this box is definitely not on the path. If it's here, it would connect to this 4, which is not allowed. If it's here, it would connect to this 4, which is not allowed. And if it's here, it would connect to this square, which is either a 2, well, it can't be a 2, or a 7, although 7's too small. So the 2 in this box is not on the path. Unfortunately, that doesn't tell me where the 2 is or where the path is. I think I've seen something. Let me have a look. I hope I'm not missing something really easy. It feels very difficult for this to be a 7. Just somehow. I don't know why, but it just feels like that can't be 7. No, I suppose it could. Couldn't it? No, it couldn't. Yeah, this might not be what they intended me to find. But think about what happens if this is a 7. Then that makes this a 2, because it can't be a 7. And we know the path must avoid the 2, so the path goes this way around. Now, if that's the 7, then that's a 3. Wait, no, does that still work? Yeah, if that's 7, that's a 3, because it can't be a 7. This has to be a 7. In order to be big enough. And then there's nothing left for this because it would be a 6, which is too small. Yeah, that's very difficult. This can't be what was intended to be found. But, okay, suppose this were 7. Now, this sees that square, and it's either 3 or 7, so it must be 3. This is on the path, and it must be next to something big enough, so that's a 7. Then this must be a 6, because it's the only thing left in this row. But that would make this a 2, because 7 and then 2. We know we have to avoid the 2 in this box, so I have to go this way around, but along the way I go a 3, 6, and those are next to each other, and that's not allowed. Gosh, that's tricky. That can't be, there has to be something easier. I'm sure you guys will find it. So that's not a 7. Okay, that's going to help me a lot, because there's only one spot left for the 7 in this box, and it's there. That means this has to be a 6. That has to be a 7. This has to be a 6. This has to be not a 6. Oh, actually, this is not a 3, because 3, 6 is too small. So that's a 7. Whoops, didn't mean to do that. Sorry. That's a 6. That's a 7. That's a 3. That's not a 3. There's only one place left for the 3 in this box now, and it's here. and I should be just finishing up. Oh, well, the path definitely can't go this way. Why? Because there's a 3 and a 4 next to each other. So this part of the path is unused, so this part is used. So we figured out the path to find the cupcake. We haven't yet filled in all the numbers. Oh, I see, yeah. That's too small if it's a 2, so that's an 8. Therefore, that's a 2, that's a 1, that's an 8, that's a 2, that's a 1, that's a 2. All right. Experiment completed successfully. Cells visited 41. Finks continues to surpass predicted outcomes across all 4 cognitive performance metrics and will therefore progress to a full-size maze in Stage 3. Okay, so we probably are going to get a full 9x9 Sudoku with no further training required. Just over an hour, not too bad. I can't remember how long it took me to solve this the first time, but I don't think it was nearly this long. Maybe it was. I don't know. I'll have to check. Anyway, that is going to be it. Thank you so much for watching, and yeah, I will be back next time with the 3rd puzzle in the series. Bye.